Hello, friends, and welcome to this session, the quantitative ability session. And in this session, we will be discussing the classification of numbers. So, welcome to all here. And I, Ankur Agrawal, is discussing this topic, the classification of numbers. Now, if I talk about the number, so number is a little important part with respect to different examinations, right? If I talk about the CAT, Z, Symbiosis, IFP, MAT, CMAT. So in all these examinations, you will be finding questions based on numbers. And if I talk about the numbers, so number will be clubbed maybe with a percentage, maybe with a profit and loss, algebra, geometry, permutation, combination. So many times you will be finding questions based on numbers which are having a multiple concepts application. Right? And in almost all the examination, approximately one third questions will be there related to numbers out of the total number of questions in the quantitative section. So, starting with this topic, that is numbers. Now, if I talk about the numbers, so there are various topics, subtopics rather, classification of numbers, divisibility rule, remainder theorem, cyclicity, unit digit, LCM, HCF, base system. So there are various subtopics under the numbers. Okay. Yes. Paras. Yes. There are various topics under the this one topic, that is numbers. Right now. So when we're talking about the questions based on a numbers, so there are various names, nomenclature are there, which are having a numbers. Right. If I say natural number, if I say real number, imaginary number, so I should know if I'm talking about natural numbers. So what is the range of number I should take? If I take fractions, so what is the kind of numbers I should take? Right. So for this purpose, this class is a little important, that is a classification of numbers. So here we are classifying a different type of numbers, and then we are identifying okay, these are the subcategories, these are the parent number, these are the child number, and so on, and this is the number 3, right? So let's begin with this part, that is numbers, right? Okay. So first of all, what we should do, we should understand the different type of numbers, the hierarchical structure of the number tree. So go back to the schooling days, maybe a class of 8, 9, 10, right? So when you have encountered this chapter, the numbers, so the name of the chapter in major board books, NCRT books, this was named as what? Yes, this is named as complex numbers, right? Yes, 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 Priyanka, yes, absolutely correct. This is named as the complex numbers, and complex numbers are defined as what? A plus I, right? So we are writing these complex number in the form of A plus IB, where I, I is what? What? Yes, this is iota, and the value of I is under root of minus 1. Right? Now, based on this format, we can classify the numbers into the different categories, right? So, with this, I can go down, and there are two different categories of the numbers, right? And the first one, when I say B is equal to 0, and second one when I say A is equal to 0. Okay? So if B is equal to 0, IB, the right part, is completely finished. So what we are getting A, and A is what? My pure, yes, pure real numbers, right? If I say A is equal to 0, so I am getting IB, and what is IB? This is what my imaginary numbers. Right? So this way now I am categorizing and dividing the numbers into different categories. Right. Now, so how will you define? What are the definitions of these two different categories? So first, real number. Real numbers I can define as the numbers which can be represented over the number line. Right? From minus infinity to 0 to positive infinity, real numbers are what? Numbers which can be represented over the number line. Right? Yes, yes, absolutely correct. Everyone, yes. So what you can do, you can just type in the chat box, right? Whatever the definition, whatever the question you are having, or if you have some query, so what do you just raise your hand and then you will be getting a permission to unmute yourself and you will discuss your question, your query, right? But in the meantime, you can keep typing your answers, your definitions, your logic, your ideas in the chat box, right? Okay, so we are defining the real numbers. What is the real number? Real numbers can be represented over the number line, right? This is the first definition. Second definition, I can say what is the real number? Real numbers which represent the physical quantities, weight, height, length, distance, time. So all these values can be represented in the form of real number, right? Suppose if I say there is a some distance of 10 meters, so you can count how much is it 10 meters. But if I say there is a some distance 10 root minus 1 meter, so how can I calculate? There is no way to identify this, right? So real numbers can be represented over the number line and real number will represent the physical quantities, right? So this is real number. Now, how will you define the imaginary number? No, 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 not this. See, basically what we do if we are having a system, these kind of definition. So we say, what are the real number which are not imaginary, right? What are the imaginary number which are not real? So these are not the proper definition, right? If there is a term, if there is a something, right? So this should have a some unique definition, right? Now, see this. So how can I define the imaginary number? Say, for example, uh, plus 2 whole square. This is what? Plus 4, right? Minus 2 whole square. This is what? Plus 4, right? So what we have a understanding if there is a some positive quantity or if there is a some negative quantity, right? When we are doing the square, answer is always positive, right? This is a general understanding we have. But if I talk about under root of minus 1 whole square, right? What you're getting? Minus 1, right? So with this property, you are defining the imaginary numbers. So how can you define the imaginary number? Numbers whose square is negative, right? So if I do the square of the imaginary number, so we are getting the square answer as a negative. So with this property, we are defining imaginary number as the numbers which are having their square as negative, right? Okay. Now, moving further. So real numbers can be further categorized under again two categories. One is what? The rational. And second is what? Irrational. Right? Now, how will you define the rational number? Rational numbers can be written in the form of P by Q. Right? Yes, 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 absolutely. Everyone is correct. P by Q. Where the Q denominator is not equal to 0 and and P and Q are a set of what? Integers, right? If I'm not taking a this statement this way, then my definition is not complete, right? So how can I define the rational numbers? Rational numbers are the numbers which can be written in the form of P by Q, where the denominator Q is not equal to 0 and P and Q are a set of integers, right? This is the one definition for the rational number. Second definition, yes, yes. If I help you to recall, something terminating, non-terminating, repeating, recurring, right? Some this kind of, okay. Now say this. So rational numbers, the second definition which I can define here is what? Rational numbers are either terminating, right? Rational numbers are either terminating. For example, 1 by 2. That is what? 0.5. Done. Division is finished. Right. There is a no further step. So this is zero point 0.5. Division is terminated. Or, or what is this? This is non-terminating, but what? This is repeating, right? This repeating. For example, this is what? 1 by 3. So this is what? 0.333 and so on. You keep dividing, division will go on. There is a no terminating point, right? But what is there? You are getting the same sequence, same pattern, step by step, right? So how can you define the rational numbers? Rational numbers are, first definition, can be written in the form of P by Q, where the denominator Q is not equal to 0 and P and Q are a set of integers. Second definition, rational numbers are either terminating or non-terminating but repeating, right? Okay, now come to second part, that is what? Irrational number. So how can you define the irrational numbers? So irrational numbers I can define as what? That is non-terminating and what? Non-repeating, right? Non-terminating, non-repeating. If you divide, you will keep dividing and there is a no termination point, right? The division will go on till infinite. And the best example for this is what? Irrational number. We are having a pi, right? What is the value of pi? This is 22 by 7, or we are saying this is 3.14, right? Or in geometry, normally we are taking this is 180 degrees, right? So you can say 22 by 7 is what? In the form of P by Q. 7 is not equal to 0 and 22 and 7 both are integers. So pi should be the rational number, but 22 by 7 is what? Just the approximate value of 3.14, right? When you divide 22 by 7, after a certain number of steps after the decimal, you will get a some pattern, some sequence, right? So 22 by 7 is not the actual value of pi. Actual value of pi is a non-terminating and non-repeating in the nature, right? So here we are having what? Complex numbers. Complex numbers are real and imaginary. Then real numbers are what? Rational and irrational, right? Okay. Now moving down further. So now we are having a rational numbers, right? So rational numbers can be further categorized under a some categories, right? So this is rational number, right? Rational numbers can be written under a different categories. So first is what? Integers, and second is what? This is fraction, right? So how will you define the fractions? So fractions are the numbers which are having a some decimal part, right? So we are having a different type of fractions. One is what? Proper fraction. So proper fraction is what? That is when numerator is what? Less than denominator, right? Numerator is less than denominator. For example, 1 by 2, 2 by 3, say 3 by 4, and so on. Right? Second is what? We are having improper fraction, right? Improper fraction. And here, this is what? Numerator is what? Greater than denominator. Right? So, how will you define this? That is, say, 4 by 3, 5 by 4, and so on. Right? So, these are what? Improper fraction. And then one more type which we have here is what? That is mixed fraction, right? So suppose you are having a one improper fraction which is say 3 by 2, right? And this can also be written as what? 1 1 by 2, right? So basically, improper fraction and mixed fraction are the same thing, just the difference in their representation. So if I'm just writing a 3 by 2, this is known as what? Improper fraction. If I'm writing a mixed fraction, so what I'm doing? 1, a complete number, and 1 by 2, a fraction part. So this is 1 by 2, what? Mixed fraction. So proper fraction, improper fraction, and mixed fraction, right? Integers, integers can be further categorized under a different categories, right? So first is what we are having. Yes, what this is whole numbers, right? And then we are saying this is what negative, right? So negative numbers are what numbers starting from -1, -2, -3, and so on. Whole numbers start from what 0, 1, 2, 3, 4, and so on. Right? Now from the whole numbers, if I am taking out what 0, right? If I'm taking out 0, so what is the leftover part? This is called as what natural number. So natural numbers are what? These are the counting numbers, right? And number 1, 2, 3, 4 till positive infinity, all are what? These are the natural numbers, right? So this way I am dividing all the different type of numbers. This is my classification of numbers, right? So if I go back here, done. So first the complex numbers, then real and imaginary, real are rational and irrational. Then rational numbers can be what? Integers and fractions, right? Yes, yes, yes. Absolutely correct. Absolutely correct. Integers are what? That is the whole number and the negative number, right? Whole numbers, if I take out the zero, so what is left over with me? That is a natural number. So these are the different type of numbers, and what I should do, I should memorize the name, the nomenclature. I should know the range of different names, so that whenever you're solving a question based on, say, algebra, in functions, in equation, etc. So when this is saying, suppose x is a set of natural numbers, so I should know what range I should consider for this, right? So this is the reason this part is a little important to understand. Okay. Now moving further, so just recapping and revising all the definitions here. So first is what? The real numbers. So how do we have defined? Real numbers can be represented over the number line, right? And real number represent the physical quantities, right? Imaginary numbers are the imaginary part, right? And here we are having an under root of -1, that is iota part of these imaginary numbers. Rational numbers. So how can you say rational numbers can be written in the form of P by Q, and second definition what? Terminating or non-terminating, but repeating, right? So now if I come down here and see this one example, so what is there? Now see, rational numbers, how can you define? One form is P by Q form. One is you are saying non-terminating, repeating, etc., etc., right? So if this is the one question, this is find the number 1.454545 till infinite, right? And this is what? Non-terminating but repeating form, right? Non-terminating but repeating form. And if you want to convert this into the form of P by Q, right? That is in the numerator and denominator. So how can you convert? So we have a very standard process for this. Yes, yes, absolutely correct. Yes. So what I suggest everyone should solve this and give me the answer in the chat box, right? And while I'm here also just discussing this. Okay. So what to do? Just take this number as x. Okay. So x is equal to 1.454545 and so on. This is going till infinite, right? Now, in this, if you notice that there are two digits, 4 and 5, which are repeating multiple times, right? So, what we do, whatever the number of digits which are repeating, take those digits before the decimal exactly once. So, you have a two digit, 4 and 5. You want to take these before the decimal. So I can say this is my equation number 1. Okay. Then if I'm taking 4, 5 before the decimal, so what I can do, I can multiply this with 100. So 100x is equal to what? 145.454545 and so on. And this I take my equation number 2. Right? Now subtract what to do from equation number 2, subtract the equation number 1. Left part to left part, right part to right part. So what is you are getting? 100x minus x. This is the left part equal to what? 145 minus 1. Right? Because 0.45, this will cancel out each other from equation 1 and 2. This is the leftover part. So if I simplify, 99x is equal to what? 144. Right? And here I can say x is equal to what? 144 divided by what? 99. Right? So simplify this. So when you simplify, taking a say 9 as a common factor out, you can say this is 16 by 11. Right? So 1.454545, which is a what? Non-terminating but repeating number, can be written as what in a p by 2 form? 16 by 11. Right. So this is the way we are converting the rational number of one type to the other type. Okay. Right. Now moving further. Now some more definitions for classification of number. Irrational numbers. So first definition I can say cannot be written in the form of p by q, right? Or m by n, whatever, or a by b, whatever you can take, right? And second definition, what I can say, irrational numbers are non-terminating but and non-repeating, right? Then what we have integers, right? We have integers. So integers are the form of what? Having a 0, 1, 2, 3, 4, and so on. Right. Minus 1, minus 2, minus 3, and so on. Right? So now coming down, and then after the integers, what we have? Fractions. So as we have just discussed, proper fraction, improper fraction, mixed fraction, and so on. Right. Now after this, what is there? We are having whole numbers, natural numbers, right? So whole numbers start from 0. If you take out 0 out from the whole number, so what is left over? Natural number. Natural number are the counting number from 1, 2, 3, 4, and so on till positive infinity, right? So this is what my num different numbers. Now, one important part is what? Prime number. So how will you define the prime number? So prime numbers are the numbers which have exactly two factors, right? One and the number itself. So if I go with this definition, so I can say 2. 2 is what? My first prime number, and 2 is the only even prime number. The second is what? 3. 3 is the first odd prime number, right? So if I say apart from 2 and 3, right? Apart from 2 and 3, the first two prime numbers, all the prime numbers can be written in the form of what? 6k plus minus 1, or I can write them as a 4k plus minus 1, right? Take the example of 5, right? So 5, you can write what? 6 into 1 minus 1, right? If you want to write 11. So 11 is what? 6 into 2 minus 1. So all the prime number except 2 and 3 can be written in the form of 6k plus minus 1 or 4k plus minus 1. Right? But the reverse of this statement is not true. If you say there is a one number which can be written in the form of 6k plus minus 1 or 4k plus minus 1, then this number should be a prime number. No, this statement is not correct. For example, see here, suppose if I say 25, right? 25 is what? 6 into 4 plus 1, right? So you can write 25 in a 6k plus 1 form, but 25 is not a prime number, right? So one directional statement is correct if there is a one prime number greater than 2 or 3. Then the prime number can be written in the form of 6k plus minus 1 or 4k plus minus 1, right? But if there is some number which can be written in the form of 6k plus minus 1 or 4k plus minus 1, then this should not be a prime number. This is not a compulsory, right? This may or may not be the prime number, right? Now, composite number. So, composite number are the numbers which have a factor as one number itself and some other number. So, there must be a three. There must be a three factors, at least three factors for a number to become a composite number. So, how do we define prime number? There should be exactly two factors. Number one, right, and number itself. Then these are the two factors. For the composite number, number one, number itself, and some other number. So there should be at least three factors. So with the definition of the prime and composite, right? Number one is the neither prime nor composite because number one is having only one factor, which is one itself, right? So for becoming a prime number, there should be exactly two factors. For becoming a composite number, there should be what? At least three factors, right? So this is the reason that number one is what? Is not a prime, not a composite. So first prime number is 2, which is only the even prime number. Second prime number is 3, which is the first odd prime number. 4 is what? First composite number, right? So prime and composite. Okay. Now, co-prime. So prime is what? A type of number, right? One single number can be a prime number. I can say 2 is a prime, 11 is a prime, right? 19 is a prime, right? But I cannot say one single number is a co-prime. So co-prime is what? A relative property of the number, right? And how can I find? When what? When the highest HCF, highest common factor of the given number is 1, then I can say number are co-prime, right? So for example, if I say 2 and 3, yes, they are co-prime. Both are prime, they are co-prime. If I say 7 and 15, right, they are co-prime. 7 is a prime, 15 is not a prime, but yes, they are co-prime because highest common factor is 2. If I say 4 and 9, right, they are also co-prime. 4 and 9, and none is a prime number, but still they are co-prime, right, because highest common factor is 1, right? So co-prime is what? A relative property of the number, but prime is type of number, right? So see here, one number one, right? Number one is a co-prime with any other number. Yes, of course, because take example 1, 2, 1, 3, 1, 5, right? 1 and 11, 1 and 12. So what is the highest common factor? 1 only. So 1 is always co-prime with all other numbers. Two consecutive numbers are always co-prime. Yes, because say 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. One is a even, one is a odd, right? So if one is a even, one is a odd, what is the highest common factor? 1. So they are always co-prime. A prime number is a co-prime with all other number except the multiple, right? So just understand this. If I say 3, right? So for 3, I have say 6, 9, 15, 21. All these are what? The multiples of 3. So 3 and any multiple of the 3 will not be the co-prime. But if I say other numbers which are not multiple of 3, for example, like 5, 8, right? 20. So these are all what? These are co-prime with 3. Done. So because they are not prime, but still they are relatively co-prime because highest common factor is 1. And yes, last point, two prime numbers are always co-prime. Yes, of course, because highest common factor is 1, right? So these are what? Co-prime, prime number, composite number, etc. So coming now, okay. So now just apply all the things, whatever we have done here, whatever we have discussed here, all the different classification of numbers, different type of numbers which we have discussed. So yes, so this first question is saying which of the following is are true. Okay. So you have the first statement, pi is a irrational number. Okay. 22 by 7 is an irrational number. Okay. 0 is an irrational. So quickly, everyone, just tell me कि out of the 1, 2, and 3, given the options, 5 option A, B, C, D, E, what do you think which option should be correct? Okay. Yes, just quickly, everyone, just quickly tell me which option should be correct. Yes. Okay. Okay. Now I'm getting some options, some answer. Okay. Yes. Priyanshu, no, no, not this. This is not the correct one. This is not the correct one. Just check again. Okay, now see this. So this is which of the following is are true. First statement, pi is a irrational number. Yes, pi is a irrational number because the value of pi is what? Non-terminating, non-repeating. So this statement is true. First one. Second, 22 by 7 is an irrational number. No, this is not. The value of pi we are normally taking 22 by 7, but this is what just the approximation of 3.14, right? So this second statement is not true. Zero. Zero is what? A part of whole number, right? So whole number are the part of integers and integers are the part of real number, right? So this is not irrational number. So this is also not right. So here I will be marking only option A, right? That is only one statement is correct that pi is an irrational number, right? Getting this? So these are the fundamental based questions which you normally get in the examinations, right? Okay. So now moving further. Okay. Yes. Now this is in a New Delhi. The buildings are numbered from 1 to 100. Okay. Then how many fours will be present in the numbers, right? So you're counting, there is suppose a row of 100 buildings and you have 1, 2, 3, 4 and so on till 100, you are giving them a serial number, right? I just want to know okay, in the serial number from 1 to 100, how many times I have written digit 4, right? How many times I have written digit 4? Okay, so yes, quickly tell me. You have the four option and you have to pick the best possible option out of the given. So no, 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 Sandeep, no, not this, not this, not this. Just check again. You're very close. You're very close. Yes, yes, Tushar. Yes, correct. Yes, yes, correct. Okay. Okay, now see this. So digit 4, I need to count how many times I am writing digit 4. So just identify where will you write the digit 4. So see, 4, right? 14, 24, 34, 44, and so on till what? 94, right? So now what you're doing, you're writing digit 4. How many? 10 times 10 times at unit place. 4, 14, 24, 34, 44, 54, 64, and so on till 94, right? Now, you are having a one series 40, 41, 42, 43, 44, 45, and so on till what? 49, right? So now you're writing 10 times at what? Yes, at what? This is tens place, right? So digit 4 is written 10 times at a unit place, 10 times at a tens place. So how many times we are writing? This is total 20 times, right? So my option 3 will be the correct answer, right? Got this? Option 3, 20 will be the correct answer. So in a sequence from 1 to 100, I have written 4. How many times? How many times? 20 times. 10 times at a tens place and 10 times at a unit, right? Okay. I suppose you are getting a say understanding and the clarity of the concepts for the classification, right? Okay. Now, this says P is a prime number greater than 5. So greater than 5, you can take a 7, 11, 13, 17, 19, 23, etc. etc. What is the remainder when P is divided by 6? Okay. So if you take a say 7, right? 7 divided by 6, right? What is the remainder we are getting here? 1. Right? If you are taking 11, right? 11 divided by 6. So if you are taking a remainder, what is the remainder? 5, right? If you are taking a say 13, right? 13 divided by 6. What is the remainder you are getting here? 1, right? Suppose if you are taking a number 17, 17 divided by 6, right? What is the remainder you are getting here? Yes, what is the remainder? 5. So, what's the answer? Yes, everyone. If you're having a some prime number which is greater than 5, if you divide this by 6, you will be getting either the 1 or the 5 as a remainder. So, which option I should mark? The third option I should mark here, right? And this is the way I am getting my answers correct, right? So what is my say to you, just revise the concept properly, understand the concept properly, so that you will be solving the question quickly and fast, and yes, with almost 100% accuracy, right? Okay, now moving further. Done. Now, so this says Shaurya writes first 100 whole numbers. Let A and B with the number of what? Number of times he write 0 and 9 respectively. What is the value of A plus B? Okay. So this is basically what? The extension of the previous example, the question which we have just discussed, that is how many times you will be writing 4, right? Now here we are having a 2-digit 0 and 9. Okay, so yes, everyone, just give me some values, some answer here, some answers, some value here. Yes, yes. Okay. Yes, yes. Absolutely correct. Absolutely correct. Now see this. The catch is here. What? First 100 whole numbers, right? So whole numbers start from what? Yes. Whole number, if I say whole numbers start from what? Zero, zero, 1, 2, 3, and so on. And this is he is writing first 100 whole number. So the counting will go on till what? 99, right? This will not go till 100, right? This is a very important catch point here, because he is writing first 100 whole number. He is not writing whole number till 100, right? So first number will be 0 and last 100th number will be 99, right? Now, A, what is A? The number of zeros, right? So 0, 10, 20, 30, 40, 50, 60, 70, 80, and 90. How many times? This is 10 times, right? This is 10 times. And second is what? 9. We have just seen the example of the 4, right? So 9 will come at what? 9, 19, 29, 39, 49, right? So 10 times at a unit place. Then 90, 91, 92, 93, and so on till what? 99. 10 times at a tens place. So 9 will come how many? 20 times, right? 10 times at a unit place, 10 times at a tens place. So if I add this, so this is coming out to be 30, right? So my option which is correct is what? Second option, right? So Shaurya is writing all these whole number, that is the first 100 no whole number. So 0 will come 10 times, 9 will come 20 times, and the total summation is 30 times for these two digits, right? Okay. So this is the way we are solving the questions, right? We have to be very comfortable with the concept. I should memorize the range of the given number, whatever the natural number, real number. So I should have a clear clarity of the definitions, right? If you're defining the real number, rational number, so what are the range of these numbers? So what I suggest, just go through the study material which you have got from the head office, right? And revise this part, that is the classification of the numbers, and solve the questions based on the classification of the numbers, right? So with this, we are winding up the session for today, right? Thank you very much. And if you have some questions, some queries, some doubt, so all these things are always welcome in the doubt session, right? So thank you very much.